Foundations of Amateur Radio. On your amateur radio journey, you'll likely discover that many transceivers run on 13.8 volt DC, give or take. For example, my FT857D requires 13.8 volt plus or minus 15%, with a negative ground and a current draw of 22 ampere. More on that later. In other words, the power supply needs to be between about 11.7 and 15.9 volts. The same voltage that runs most vehicles, with some wiggle room for fluctuating alternator charging cycles. While some radios will absolutely fit in your car, there's plenty where that just isn't the case, even though they're set up for a 13.8 volt power supply. You might think of it as an anachronism, a few steps removed from spark gap transmitters, but there's more to the story. Most residential power grids run on AC power, at varying voltages and frequencies between 50 and 60 Hz. Across the world, there's 8 different AC voltages in use between 100 and 240 volts. Some countries use more than one combination, and I haven't even looked at three-phase power. Perhaps 13.8 volt DC isn't looking quite as odd. With this revelation comes the need to actually have 13.8 volt available in your shack. Converting your grid power to something you can plug your gear into requires some form of transformation, typically achieved with a power supply. Efficient, cheap and plentiful, the switch-mode power supply is the most common. Built to a price, they're also often noisy. Not just the fan, but noisy from a radio emissions perspective. Amateur radio has very sensitive receivers, and as a result you can often hear, or see if you have a waterfall display, RF birdies, a sound reminiscent of a budgie whistling every 100 kHz or so across the whole radio spectrum. Not something most other equipment cares about. So you're often left to fend for yourself in figuring out how to deal with this phenomenon. There's plenty of filtering techniques and circuits to be found, and some of them even work. But for my money, I'd spend it on a power supply that doesn't make noise in the first place. A regulated power supply maintains a constant output voltage or current, regardless of variations in load or input voltage. An unregulated power supply can wander all over the place. Adjustable power supplies allow you to set the voltage, amperage, or both, sometimes with knobs, sometimes using external controls. At this point, you might decide that this is all too hard, and you want to do away with all this complexity and use a sealed lead acid or SLA battery. After all, that's what the 13.8 volt is based on. But then you'll need to charge it. Similarly, picking any battery technology requires some form of charging. Another word for charger is power supply, often a switch mode one, and likely not filtered in any way that matters to you, since batteries, and for that matter solar power inverters, are unlikely to care about RF birdies. I will make mention of linear power supplies. When I started on this journey, this was the strong recommendation from my peers as the most desirable option. Although they are significantly less efficient than switch-mode power supplies, only 30% versus better than 80%, from an RF perspective, they're extremely quiet. Of course, the lack of efficiency reveals itself in the form of heat, which necessitates the application of cooling, from a fan, often a very noisy fan. One potential source of power supply is a computer power supply unit, or PSU. Before you go down that route, consider that they're intended for installation inside a case, often generate various voltages at very specific current draws, and are not typically known for being RF quiet. After weighing up all the variables, I chose a laboratory-grade switch-mode current-limiting adjustable power supply. It's set to 13.8 volt, and it sits on my desk doing its thing. Rated at 1 to 15 volts at 40 ampere, it's now as old as I am in amateur radio terms, well and truly a teenager. It's also overkill. by quite a margin. Remember when I mentioned that my FT857D is rated at drawing 22 ampere? As a QRP or low power station, I typically use my transmitter set to 5 watt. But even when others use it at full power, I have never ever seen it draw more than 12 ampere. That's not to say that it can't draw 22, I've just never seen it. As a benefit of having such a massive overkill in the specifications of my power supply, I can power more than one radio and not notice. Not that they're all transmitting at the same time, or using more than 5 watt, it just doesn't matter. I previously discussed setting a standard for coax connectors in the shack. The same is true for deciding what to pick for power supply connectors. In my case, I chose Anderson power pole connectors. Pins come in 15, 30 and 45 ampere ratings. Are genderless and housings are available in many different colours. When I say genderless, it means that you can join two identical connectors. Within my shack I use the RACES or ARES power pole wiring standard, and every single 13.8 volt connection uses it. If I get new gear that uses some other connector, I'll cut the power supply wire in half and terminate both the power supply and the cutoff cable using power pole connectors. That way my gear will connect to my own power supply and I'll have a universal adapter cable when I need it. Over the years I've collected an impressive array of adapters using this method, and it's helped immensely when sharing gear with other amateurs. Word of warning: make sure you get positive and negative the right way around when you join your power pole connectors, and make sure that you have the red and black housings the right way around too. You can thank me later. If you do this more than a few times, I'd recommend that you spend the money on a proper crimping tool. It makes the experience so much better. To avoid many of the pitfalls of interference whilst connecting power and coax to the same radio, try hard to avoid running both in parallel, or worse, joined to each other. Instead, attempt to run them in different directions, and only cross at right angles if you have to. One thing to consider is the ability to switch everything off immediately. To that end, I have a power switch on my desk that isolates all power to the equipment. You'll notice that I have not said anything about grounding or earthing. That's on purpose. Your laws and mine are not the same. Similarly, information you'll find online rarely, if ever, describes the jurisdiction it applies to, so look at your own rules and implement accordingly. I'm Ono, Victor Kilo 6, Foxtrot Lima Alpha Bravo.